Let's now talk about function scope and lifetime. We are going to understand how functions are going to treat all the variables that we are creating. Now in Python, variables have scope, which where they can be accessed. Scope basically defines where exactly your variables can be accessed and where not. And lifetime defines how long they exist. Now variables are created when a function is called and destroyed when it returns. So one thing that we need to understand is that a variable is destroyed as soon as the function halts. Let's understand this with the help of an example. Let's create a file called functionscope.py and let's write a function called sum. Now this is a very basic function that simply sums two numbers and it returns C and it takes A and B. Let's say I print sum of let's say I print sum of 4 and 6. Let's change a setting in VS Code. I'm going to change a setting in VS Code, which is to autocomplete parentheses. So I'm basically auto-completing parentheses whenever I write a function. So let me write Python and then function. Okay, so this is the setting, add parentheses to function completions. So what this will do is it will automatically add parentheses for me. And if you want, so let's say if I write print, the parentheses are automatically added for me. If you don't want this setting, you can always turn it off. But for now, I'm going to turn it on because it's really very useful while writing Python programs. So if I do print sum 4,6, it's going to output 10. No surprises there, right? 10 is the output. But let me show you something. What if I print C? Can I print C? It's already showing me error, but let's try to print C. It says, hey, you can't print C, it's not defined. But you might argue that it's defined inside sum. So the thing is, Python doesn't work this way. The thing is, when you write sum 4,6, 4,6 are passed as A and B to this function. The moment you pass 4 and 6 to A, B, A is 4, B is 6, and C becomes 10. Now, once C becomes 10, what will happen is it will be returned. And once it is returned, A, B, and C will be wiped out of memory. And that's how function works. Function only keeps variables until it returns. And after that, it deletes all the variables, kind of, okay? So in this case, we can't access A, we can't access B. And if you try to print A, this is an error. If you try to print B, this is also going to be an error. Because when you say sum 4,6, 4 is assigned to it temporarily until function returns, and 6 is assigned to be temporarily until function returns. And this is why you can't access this variable. So we call this variable as local variables. So I'll write down a comment here. I'll say A and B are local variables. What does it mean? It means that you can only access these variables inside a function. You can't access them outside the function. But let's say I want to access a variable everywhere in the program. And in that case, what I can do is I can write that variable here. If I say z is equal to 8, I can access this from anywhere. Anywhere means anywhere. Let's try to access it from here. And if I run this program, you'll see that I can access z from this function. And the reason of this is that z is a global variable. So let me write it down here. Z is a global variable. Okay, so z is a global variable. Now let us say I want to change z. I want to change the value of z. I want to say z is equal to 1. Let's say I want to do that. And then I want to print the value of z after changing it. So I said z is equal to 8. Z is a global variable. I can technically use it everywhere in the program. We just saw the definition of global variables. I can print sum 6,4 or 4,6, which will give me 10. That's also easy and straightforward. Now, if I say z is equal to 1 here, does it change this z? And the answer is no, it doesn't. Whenever I say z is equal to 1 like this, it creates a local variable called z, and that's the default behavior. It creates another local variable called z, which destroys itself, or maybe which is destroyed after this function returns. Okay, so this is destroyed right after this function is returned. So if you try to print Z here, you will get 8 and not 1. If I run this program, you will see 8 is printed. And if you run this program, this will also print 8 because Z was 8 and then we ran sum 4,6. Then once again Z is 8 because this will not change the value of Z because this is another local variable. So we can have two variables of same names. So one as a global variable and one as a local variable. And we can even have more than one instance of Z is equal to 1 in different functions. So let's say I have another function called greet. I can have something like this. And if I say Z is equal to 32 and if I return, say I return 0 or maybe I don't even return, I don't want to return anything. So Z is equal to 32 will be created as a local variable, just like Z is equal to 1 is created as a local variable here. So Z is equal to 1 is a local variable in sum and Z is equal to 32 is a local variable in greet, and Z is equal to 8 is a global variable because it's not inside any function. So this is how local and global variables work. Alright, we studied a lot. Let's recap things. Types of scope in Python. One is local scope or variables that are declared inside a function and they are only accessible within the function. Let's talk about global scope. They are declared outside any function and can be used throughout the program. Okay. And this is the example of a global variable. My func x is equal to 5. 5 is a local variable. X is a local variable. The value is 5. And then I can execute this function. And if I print x, this one it will be printed, not this one because this is destroyed right after this function returns. Okay. Now let's talk about global keyword. This is very important and very exciting. Global keyword is used to modify global variables. And I want to dedicate another program to this. So let's understand the global keyword. Let's understand the global keyword, global.py. Let's say I have a function and let's say it's called sum a comma b, and let's say I want to print hey, I am summing, and let's say I want to say c is equal to a plus b, and let's say I'm returning c, and I can say print sum and 3 comma 12, and the output is going to be 15, and we'll also see this print statement. But for some reason I have z is equal to 3 here and I want to modify this value, and let's say I print z here and it will not change. I know it will not change because we have already seen that, right? It's a global variable, it cannot be changed. If we print it here, it will not change, okay, because it's a global variable and we have not done anything inside some function. It has no reason to change. But if I do something like z is equal to 0, will it change? No, it will not be changed because it's a global variable, right? Declaring another z is equal to 0 inside another function is not going to change it. So let's run this program. Let's run this program and let's see what happens. So we have this 15 and 3 printed on the screen because z is 3 and not 0. But I actually want to change. This variable here. I want to update the global variable. Now, what I can do is I can write global z, and this is basically telling my Python interpreter that please modify global z. I'm instructing my interpreter, please modify global z. And if you want to do this, you can always write global z, and now it will refer to the global variable z. It will refer to global variable z and it will not create a new variable. This will refer to global z and not create a local variable. Okay. So global keyword is simply used to modify global variables. Okay. That's it. So I had a global variable called z is equal to 3. And I can always modify this inside a function. So sometimes a question is asked in interviews and it's, can you modify a global variable inside a function? The answer of that question is yes, we can, but we'll have to use global. Okay, that's awesome and amazing. Now, this line is very important. While this will allow the function to change global variables, excessive use of global is discouraged and it can make debugging harder. Because if you write a lot of globals, you'll have to track everything and it will be difficult for you to track which function is changing that global variable. I hope you got that point, and this is why the use of global keyword is discouraged. In fact, the excessive use is discouraged, and sometimes you can use it when you like or whenever you feel convenient. And that was global variables in Python. You can always access this handbook and do your revision. Very, very important for you to revise all the concepts. And let's now talk about docstrings, a very important topic. So what are docstrings? Docstrings are used to document functions, classes, and modules. In Python, they are written in triple quotes. They are accessible using the __doc __ attribute. Here's an example. So let us say you want to add some info to your function. Let us say we have a function. Let's create another program called docstring, docstrings.py. Let's write this function. And what we can do is we can make it very, very straightforward. Now let's say I want to define what this function is exactly doing. I can write triple quotes and I'll say this will sum two numbers. Okay. Now if I do print sum, which is the name of my function, and if I do __doc __, it will print this information. And this information is called docstring. Now it might look like a regular Python comment, but if you write it right after starting the function, it's called docstring. And if I run this program, you'll see that this docstring is being printed. Now, why is it designed? Why is Python designed to have docstrings? Python is designed to have docstrings because we sometimes want to attach information to a function. We want to attach information on what variables it is taking as parameters, what variables and type of variables it is returning. And all these things are very, very important. So we simply do sum dot __ doc to get that information. And this information is also available when we hover over this function. So if I hover over this function, you'll see this will sum two numbers. Any information that you want to add to a Python function, whenever user hovers over it, you want to add that to docstring. Now, the thing is, a lot of people will use your functions. If you package your functions as a module, people will use them. And it's your responsibility to guide them how to use your functions. What are the values acceptable? What are the values not acceptable? And how they can make the most out of your function. And this is the information that you can attach with your function. Now, let's see an example of writing a detailed docstring. So I've included an example where we include everything, a multi-line docstring. By the way, you can have multi-line docstrings. So this multi-line docstring is basically explaining everything about this add function. So this returns the sum of two numbers. Okay, there are two parameters. A is of type int, B is of type int. A is the first number, B is the second number. All the information associated with this add function is added here. And what does it do? It basically helps fellow programmers to make the most out of this function. And it is also telling me the return value is int, the sum of the two numbers. Technically, you can write anything inside these triple quotes, but you want to include the information that programmers will find most useful and that will guide them to use your function in the most convenient way possible so that they can make the most out of your functions. All right, we studied a lot so far. So functions help in reusability and modularity. They can take arguments, they can return values. We talked about lambda functions. We talked about recursion, which is a technique when function calls itself. Then we talked about modules that help in organizing code and using external libraries. Scope and lifetime of variables decide their accessibility. And we talked about docstrings that are used to document functions, classes, and modules. Awesome. So I hope you are having a great time enjoying this course. And I use the word enjoy because you have to enjoy this learning experience. And I am dedicated in making your learning experience as enjoyable as possible. I hope you are enjoying this course. See you in the next video.